we're going to consider the differential equations in the form mxy dx and nxy dy is equal to 0 below. For each one, we want to determine whether our m and n are homogeneous functions, and if they are, we want to state the degrees. So to find if something is homogeneous or not, we want to combine the variable t with the current variables inside, whether they be x or y. So if we look at a, for example, we are going to have a tx plus a ty dx and then plus tx right here. Now what we can do is factor out the t's from the front, and we would essentially have t and then x plus y dx plus tx dy equal to 0. And so for each of these parts with our m and n, we only have one t out front. And since we do, it is a first order homogeneous function. For this next one, we're going to do the same thing. We'll have a t squared here because our x is squared. We'll have a t squared here and a t here. And if we look at this, you can see that we are going to have a t squared in the first one and then a t cubed in the second one. So this means that it is not homogeneous because they have a different order. Now looking at the c, we have a t out here, and then we're going to have a t here with a t with our ln's. Now if you look carefully, you can actually see that we can combine these ln's because we have a minus in between them. And that's just going to leave us with an ln. We have our tx over ty. So this is going to be our answer right here, what we have. And from this, our t's can cancel out. So that means we're only going to have a t in front of both of these, meaning it is also a first order homogeneous function. And for this last one, if we put in t's with the x's and the y's, there's no way to actually bring it down. And so since that is the case, this is not a homogeneous function. Click the playlist in the description below that like button if you want to see a continuation of this problem, which is where we will actually go and solve for the homogeneous ones, which are A and C. It's pretty cool, so don't miss that, and I hope it helped.